Hi, my name is Dr. Yani. Okay, so yesterday I forgot to introduce myself. So okay, basically I studied Bachelor in Fishery Science in UMT, and then I continue my Masters in Marine Biology from Bangor University in Wales, United Kingdom, and then I proceed my PhD in Marine Science in UKM, University Kebangsaan Malaysia. So I just recently finished my PhD and I got a position as a lecturer in UMT. Okay, so today I'm going to do some introductions on fisheries oceanography. Okay. Okay, so what is fisheries oceanography? Okay, traditional fisheries management approaches estimate population abundance level as a function of the number of spawning adults without environmental or ecological input. So, field of fisheries oceanography has provided a framework to predict recruitment and define harvest strategies within an ecosystem context. So, dahulu traditional management, fisheries management hanya menggunakan approaches estimated population. Jadi sekarang kita ada fisheries oceanography di mana kita menggunakan, we have provided a framework untuk predict recruitment, okay, dalam and define harvest strategies within an ecosystem context. So by seeking to elucidate mechanistic relationship between fish and the surrounding oceanic habitat, the field of fisheries oceanography aims to provide a solid understanding of fish behavior, population dynamic, and life history with an ecosystem perspective. Maksudnya, fisheries oceanography ini aim untuk provide a solid understanding. Kita faham tentang fisheries behavior, population dynamic dan juga life history dalam perspektif ekosistem yang luas. Okay. So, fisheries oceanography defined as the study of oceanic processes. Proses laut yang affect marine ecosystem, yang mempengaruhi marine ecosystem dan perhubungan relationship of this ecosystem to the abundance, distributions and availability of fishery species. So, primary goal adalah untuk regulate scientific information to regulate fisheries in a sustainable manner, okay, which we call as fisheries management, supaya kita boleh manage sumber perikanan kita dengan lebih baik bila kita faham bagaimana proses ocean ini mempengaruhi marine ecosystem kita. Okay. So, apa itu oceanography? Okay, as we all know, the world consists of 70% of the oceans. Jadi, marine scientists use the logic of science to study the oceans. Okay, oceanography atau kita tahu sebagai marine science is a process of discovering unifying principle in data obtained from the ocean, its associated life form and bordering lands. So marine science ada 5 disciplines. Okay, so nearly all marine scientists specialize in one area of research, but they also must be familiar with related specialties to appreciate the linkage between them. So antara 5 ni, so marine scientist akan hanya satu kepakaran, tapi kita perlu faham 5 ni supaya kita boleh relatekan salah satu dengan yang lain. Okay, antaranya adalah geology, physics, biology, chemistry dan engineering. Okay, apa itu physical oceanography? Okay, physical oceanography study and observe ocean dynamics such as currents, wave and tides. So basically an atmosphere interactions. Okay, for chemical oceanography, we study the ocean's dissolved solids and gases and their relationship to the geology and biology of the ocean as a whole. For biological oceanography, okay, we work with the nature and distributions of marine organisms. So the impact of oceanic and atmospheric pollutants on organisms. And we also study the diversity of life in the oceans and the ocean's role as their habitat. For geological oceanography, we focus on questions such as the compositions of the inner earth. Okay, we examine the compositions of marine sediments and rocks, including seabed volcanoes, seabed movement, undersea earthquake, and etc. So we also study the earth, oceans, continents, and climate. Okay, lastly, we have engineering oceanography. Okay, which we design and build oil platform, ships, harbors, and other structures that enable us to use the oceans wisely. Okay, there are 5 major oceans. Okay, jadi kita harus tahu kita ada 5 major oceans. Yang pertama, Arctic Oceans. Okay, is the smallest of all oceans. Okay, the Arctic Oceans is completely surrounded by land, mainly Eurasia and North America, with the ocean centered approximately on the North Pole. Okay, dia ada di North Pole atas sekali. Okay, so opposite of Arctic Oceans, we have Southern Oceans. Okay, also known as Antarctic Oceans. Okay, the Southern Oceans completely encircles Antarctica, flowing from west to east. Okay, and then we have Pacific Ocean. Okay, Pacific Ocean ni adalah laut yang terbesar sekali. Okay, the Pacific Ocean is the largest body of water on Earth. So located, the Southern Oceans located dekat Asia, Australia, and the land masses of the West Hemisphere. And Pacific Oceans contains almost twice as much water as the Atlantic Oceans. Okay, 2 kali ganda daripada Atlantic Ocean. Atlantic Ocean adalah world second largest, which is cover 21% of Earth's surface, separating North and South America from Europe to Africa. Okay, untuk Indian Oceans, bila kita tengok dia ada tengah-tengah Afrika tu. So dia located between Africa to the west and Asia to the north. So Australia in the east and Antarctica in the south. So Indian Ocean is the warmest ocean in the world. So kalau kita nampak Pulau Jawa berada di Indian Oceans, jadi di Malaysia, Terengganu terletak di Pacific Ocean. Kita menghadap Laut Cina Selatan. Okay. So sekarang kita berkenalan dengan El Nino Southern Oscillations atau kita panggil dia sebagai ENSO. So El Nino is an oscillation of the ocean atmosphere system in the tropical Pacific, having important consequences for weather around the globe. Jadi El Nino ni mempengaruhi, jika dia berlaku, dia akan mempengaruhi cuaca seluruh dunia. Okay, so El Nino is characterized by unusual warm ocean temperature in the equatorial Pacific. Dia berlaku di tengah-tengah ya equatorial Pacific, as opposed to La Nina. La Nina adalah sebalik, opposite face of El Nino. Maksudnya kalau El Nino membawa warm water, La Nina membawa cold water temperature. So ENSO event occurs irregularly. So it occur every 2 to 7 years. Okay, so Maulana boleh tolong mainkan video?
I think the sound is off. Molina.
Stream across the planet, driving warm surface seawaters across the vast Pacific Ocean. These sea surface temperatures create predictable patterns of circulation in the atmosphere and ocean. Climate scientists gather data from ships, weather stations, ocean robots, and satellites to measure the swing between the three phases of ENSO: neutral, El Niño, and La Niña. A La Niña event tends to bring above average rainfall to eastern Australia. During an El It influences weather patterns across the world, from America to Antarctica to Australia. From the Spanish for little boy, it's known as El Niño. Its other cycle is La Niña, or little girl. The in-between phase called neutral. The swing between these phases forms the El Niño Southern Oscillation, or ENSO, one of the most important climate drivers in the world. ENSO is a major influence on Australia's climate. El Niño and La Niña events can cause natural extreme events such as bushfires, drought, heat waves, floods, and cyclones. As the Earth spins, trade winds stream across the planet, driving warm surface seawaters across the vast Pacific Ocean. These sea surface temperatures create predictable patterns of circulation in the atmosphere and ocean. Climate scientists gather data from ships, weather stations, ocean robots, and satellites to measure the swing between the three phases of ENSO: neutral, El Niño, and La Niña. A La Niña event tends to bring above average rainfall to eastern Australia. During an El Niño event, there is a greater chance of drought and bushfires. Each El Niño and La Niña event lasts about 6 to 12 months. It takes on average 4 years to cycle from El Niño to La Niña and back again. But no two El Niños are the same. The strong 1997-98 El Niño impacted every continent in the world, causing widespread devastation worldwide. This story begins in the eastern Pacific. Here, trade winds blowing from east to west push warm surface waters across the planet, piling up warm water in the western Pacific. Above the ocean, warm air rises, driving atmospheric circulation patterns known as Walker circulation. Cold, nutrient-rich waters upwell in the coastal ocean, replacing the warm water pushed away by the trade winds. Like an athlete pumping iron, the La Niña is the muscled-up version of the neutral phase. Trade winds become strong, and more warm water builds up in the West Pacific. The excess of warm water increases evaporation and precipitation, causing floods and forming tropical cyclones off the northeastern Australian coast. This warm water escapes through the gap between Indonesia and Australia to supercharge the Lewin Current, a 5,500 kilometre long flow of warm waters along the Western Australian coast. But, like an athlete, the winds can't keep pumping at this speed forever. Sometimes the winds weaken and warm water slashes back across the ocean to the East Pacific. The Walker circulation breaks down, weakening or even reversing the trade winds. Warming of the Eastern Pacific accelerates, setting off a feedback loop that keeps most of the rain-producing evaporation in the middle of the Pacific. Due to the movement to the east of warm surface waters, northern and eastern Australia experience clearer skies, higher temperatures, heat waves, and increased risk of drought. Off the coast, fewer tropical cyclones form, as tropical activity is concentrated further east. Off the coast of South America, upwelling of cold waters is suppressed, and warmer surface waters result in higher than normal rainfalls and sometimes flooding and hurricanes. In Western Australia, the Leeuwin current tends to be weaker and cooler during El Niño events. During the 2010-2011 La Niña, marine waters that were up to 5 degrees warmer than usual caused mass deaths of marine life, as well as coral bleaching along the Western Australian coast. However, warmer La Niña waters are generally beneficial for species such as the western rock lobster, whose larvae ride the Leeuwin current southwards. In La Niña years, more lobster larvae settle to the ocean floor, meaning greater numbers are available to fisheries. 2015 is the first strong El Niño in 18 years. In the future, understanding when, how, and why these events happen will help us to manage the risks that they bring.
Australia's highly variable climate is influenced by the broad patterns in the oceans around it and the atmosphere above it. Some of these patterns are not.
Thank you, Maulana. Okay, now kita akan compare apa itu El Niño and La Niña. Okay, jadi El Niño is a warmer ocean temperature. So that warm water move eastward and then the weak trade wind akan weak and reverse. So upwelling slacks off or stops completely. So El Niño akan occur every 2 to 7 years. Drought and fire akan terjadi di Western Pacific dan tropical thunderstorm atau flooding di Eastern Pacific. So La Niña adalah colder ocean temperature. So strong trade wind in the Central and Western Pacific. So the warm water move forward westward toward Australia, causing a drop in sea surface temperature. So during La Niña, usually it will be drier than normal summers. So it will last 1 to 3 years and there will be floods in Australia. So now we're going to monsoon season. Okay, as you all know, monsoon season sangat mempengaruhi keadaan oceanographic conditions. Okay, so monsoon wind is caused by differences in physical properties between ocean and continent that seasonally reverses its directions. So each monsoon represents different characteristics in terms of wind flow, rainfall and temperature, which can affect the oceanographic conditions. Okay, di Indonesia, the monsoon system, we call it as Asian Australian monsoon, which characterized by seasonal changes in wind speed and directions. So namanya northwest monsoon during November to March, which associated with westerlies from Asia that brings warm air and high moisture and causes rainy seasons in this region. So southeast monsoon from May to September, which associated with the easterlies from Australia, bring warm and dry air and causes dry seasons in these regions. And then they also have transition monsoon 1 in April dan juga transition monsoon 2 dekat Oktober. Okay, waktu Oktober. Still di Malaysia juga sama, okay, almost the same. So the east coast of Peninsular Malaysia is also highly influenced by South China Sea monsoon. So di Malaysia we call it as northeast monsoon during November to March. Dominated the South China Sea region due to strong monsoon wind, which causes a strong southwesterly current at the east of Malaysia. Jadi Terengganu dia terletak di pantai timur, jadi masa November to March memang akan hujan dan akan strong wind dekat tepi pantai tu, kuat sangat. So okay, pada southwest monsoon, May to September. So during ni, the circulation of the shelf is directed northward. So there are also 2 inter-monsoon transitions, sama seperti di Indonesia pada bulan April dan juga Oktober. Okay, so oceans terdapat pelbagai zon. So yang pertama, the intertidal zone. So it's closest to the shore. At high tide, it's covered with water. At low tide, it is exposed to air. So living things must have adapt to changing conditions and moving water in this zone. Okay, organism yang berada di entitled zone ni mestilah organism yang boleh adapt kepada dua keadaan ni, high tide dan low tide. Okay, neritic zone lies over the continental shelf. The water is not very deep. There are plenty of nutrition and sunlight. Many organism live in this zone. Biasanya ikan akan berada di neritic zone. Okay, oceanic zone is the open ocean out past the continental shelf. Okay, the water may be very deep, nutrient may be scarce, and fewer organism live in this zone. So untuk photic zone, kalau kita nampak 0 ke 200 meter itu kita panggil photic zone, okay, is the top 200 meters of water. So this zone has enough sunlight for photosynthesis. So that's why there are more living things here than the apotic zone. So apotic zone tu 200 meter ke bawah, okay, the water below 200 meters. So there isn't enough sunlight for photosynthesis. So living things must eat whatever drift down from above or each other. So that's why there are fewer living things here than near the surface. So lastly, kita ada benthic zone. So benthic zone ni is on the ocean's floor. So the ocean floor drops as you move away from the continents. There are a few living things on the ocean's floor where the water is very deep. So, apa itu benthos? Okay, benthos is a benthic organism that either live on or in the seafloor. So, epifauna live on the surface and infauna live within the seafloor. So, epifauna are benthic animals that can be divided into two general categories. We have sessile and mobile, yang bergerak dan yang tidak bergerak. Okay, example of sessile epifauna such as barnacles and mussels. Meanwhile, example of mobile epifauna such as crabs. Okay, so example of infauna includes such as polychaetes, bivalves, and worms. So they can be both mobile and sessile. So benthic organism on the deep sea rely on the organic material that ran down from the photic zone. So in addition to the depth of the bottom environment, substrate or in which the organism live is also very critical. So rock, mud, sand and gravel each provide a different type of food, shelter or place for attachment that attracts different groups of organisms. So pelagic fish, okay, there is no distinct boundary from coastal to ocean's water. So some oceanic fish become partial residents of coastal water, often during different stages of their life. Mungkin dia akan spawn dekat coastal and then dah besar dia akan ke oceanic species. So true oceanic species spend their entire life in the open oceans. So these pelagic fish get their name from the place that they inhabit, which we call pelagic zone. So the pelagic zone is the largest habitat on Earth with volume of 330 million cubic mile. Different species of pelagic are found throughout the zone. So numbers and distributions vary regionally and vertically depending on availability of light, nutrient, dissolved oxygen, temperature, salinity, and pressure. So fish dominate the neritic zone, okay, and found at all depth and in all the oceans. So their distribution patterns are determined by their dependency on the ocean's primary producer. So pelagic fish ini dia bergantung kepada primary producers. So pelagic fish ada dua, satu coastal pelagic, satu lagi oceanic pelagic. So coastal pelagic dia berada di kawasan yang ada sunlight. Okay, which is typically above the continental shelf, seperti anchovies, okay, ikan bilis dan sardin. Okay, kalau oceanic pelagic, dia biasanya inhabit water below the continental shelf, seperti swordfish, tuna, mackerel dan sharks. So, apa itu pelagic habitat hotspots? Pelagic habitat hotspot ni adalah kawasan di mana ikan akan berkumpul. atau kita panggil hotspots lah, kawasan pengumpulan ikan yang tinggi. Okay, CPUE-nya tinggi. So dia defined as areas of high biological activity where linkage occurs between physical processes, primary production, secondary consumer, and higher trophic level predators, plays an important role in controlling distributions, migrations, and abundance for commercial and wide roaming pelagic species in many different oceans. Jadi macam mana kita nak tahu kawasan hotspots ini? So usually pelagic fish ni akan berkumpul di kawasan yang ada ocean fronts, eddies dan upwelling. Okay, apa itu ocean fronts? Ocean fronts are important as congregating spots for many valuable pelagic species. So fronts consequently have immense effect on the oceans, daripada food change ke global climate change. Okay. So ciri-ciri setiap ikan dia akan ada ciri-ciri yang berbeza bergantung kepada keadaan persekitaran. Contohnya seperti ikan sardin, kita akan jumpa observe and caught in and around a front. Okay, their distribution changes responded to seasonal variation of the front. Maksudnya bergantung kepada front. Kalau front ada di front, jadi banyak. Kalau tak ada, tak ada. So it is hence considered that the front and thermocline positions have considerably impact on sardines distributions. Okay, untuk ikan mackerel adalah spesies yang berenang, migrate dan juga berada dalam satu kumpulan yang besar. Jadi keberadaan mackerel ini bergantung kepada annual cycles of ocean productivity, reproductive cycles, ocean current and circulations. So studies showed that potential fishing ground were located near the coast to offshore. Okay, these species tend to aggregate in relation to their physical and biological indicators of the ocean's environment. Okay, untuk tuna pun sama. Okay, the biophysical environment of the transition region plays an important role in controlling tuna distributions and abundance. So several investigators found that migration distributions and availability of tuna are highly associated with ocean fronts and eddies. So recent findings suggest that frontal area, eddy field and topographic features are important habitat hotspots for pelagic species such as flying squid and tuna. So, apa dia faktor biologi dan physical oceanography yang mempengaruhi kawasan aggregation ikan? Okay, jadi untuk kita faham stok perikanan tu, kita harus faham dia punya proses yang mempengaruhi kelimpahan, taburan, migration dan recruitment ikan ini supaya kita boleh manage kita punya stok perikanan dengan lebih baik. Jadi dua faktor yang penting adalah sea surface temperature dan chlorophyll. Okay, dua ni the parameters that were often used to explain the distributions and abundance of fish based on the catch per unit effort. So variations of these two factors were used to identify aggregations area dan potential fishing zone. Okay, kenapa kita guna SST dan chlorophyll? Okay, sebab SST atau sea surface temperature is an index of physical environment that influence phytoplankton growth and control the physiology of living organism. Ikan ni dia sangat sensitif kepada suhu. Jadi suhu memainkan peranan yang sangat penting dalam pertumbuhan ikan. Okay, it is known that SST play a key role as the only environmental predictor highly related to diversity of many pelagic fishes. Okay, chlorophyll concentrations sangat penting because it's an index of phytoplankton biomass and it is the most important pigment required for photosynthesis. So it is very important oceanographic parameter in determining the productivity of the oceans and often related to fish production. Di mana ada phytoplankton, dekat situ ada ikan. Okay, so the variability of chlorophyll is related to seasonal monsoon. Okay, dia bergantung kepada seasonal monsoon which interrelated with wind, current, rainfall and river discharge. So, apa kelebihan kalau kita tahu di mana taburan dan kelimpahan ikan? Why? Why we should know? Okay, so fishes are known to find suitable habitat for feeding. Ikan ni dia akan cari tempat yang sesuai untuk dia makan, untuk dia spawning, for migration and for protections. So, taburan ikan ini adalah satu relationship yang kompleks, okay? Sebab dianya dikawal oleh several factors. Dia dikawal oleh beberapa faktor persekitaran. Jadi disebabkan kompleksiti ini makes it difficult for fishermen to determine potential fishing ground. So the majority of the fishermen apply traditional method to locate potential area of fishing activity. Jadi bila dia menggunakan cara tradisional ini, dia menggunakan kos yang banyak, masa yang lama, tapi akhirnya kos jadi tinggi dan juga profit rendah. Okay, so bila kita tahu di mana ada taburan dan kelimpahan ikan, kita boleh improve fishing gear efficiency. Kita boleh determine the potential fishing ground more quickly and accurately. We can help the fishermen to exploit marine resources more effectively and efficiently, promote sustainable fishing, reductions in searching time, mengurangkan masa, which will increase catch with lesser effort. Jadi kita boleh kurangkan masa tapi tangkapan banyak dan effort yang kurang. Okay, so critical for marine management strategies and identifying potential target for conservation. Okay, dengan advanced teknologi yang ada sekarang, kita boleh guna remote sensing. So, physical and biological features in real time can be detected by sensor of satellite remote sensing. So, this technology able to provide reliable global coverage of SST and chlorophyll at relatively high spatial and temporal resolution which can be measured from space, daripada angkasa. Okay, so this is an effective and efficient way compared to field sampling that requires time, cost and limited coverage areas. So remote sensing ini sesuai untuk kita dapatkan data di kawasan yang besar dan it can be done repeatedly in a short time. So remote sensing is a process or technique in obtaining information about an object, area or phenomenon through the analysis of data collection by recording, observing or viewing objects from a distance by using electromagnetic radiations as a carrier of information. So remote sensing ini kita boleh guna dalam fisheries research, fisheries management and catch because dia provide synoptic oceanographic measurement untuk access the influence of the environment on the abundance and distributions of fish population and facilitate analysis at communities and ecosystem level. Dia lebih menyeluruh, okay? Okay, selain daripada remote sensing, kita juga guna GIS. So dengan remote sensing dan GIS, kita boleh observe oceanographic parameters. So GIS also extensively used in marine fishery studies, terutamanya dalam menentukan perhubungan antara ikan, dynamic population ikan dengan environmental factor. So GIS teknik ni kita dah guna untuk proses satellite image. It provides integrating theoretical aspect of the oceanography and ecology approaches with spatial database and statistical function. Jadi bila kita gabungkan satellite GIS dengan statistical analysis, combine dengan in situ observation related to fish abundance, kita akan dapat cara yang lebih efektif untuk manage fisheries at sustainable levels. Okay, jadi kenapa kita perlu fisheries management? Kenapa kita perlu manage sumber perikanan kita dengan baik? Sebab the countries in the Southeast Asia regions are among the world highest producers of fish and fisheries products from captured fisheries that come from the water identified by FAO as major fishing areas. Southeast Asia ni adalah kawasan major fishing area, okay? In 2014, the world fisheries production total 195.7 million metric ton, of which 94.6 million metric ton was contributed by captured fisheries, while 101 came from the aquaculture. So of this total, the Southeast Asia region accounted for about 22%, iaitu 42.2 million metric ton, with Indonesia as the region's highest producers, regenerating about 20.6 million metric ton. Jadi banyak di situ ya. So, marine fisheries, freshwater fisheries and aquaculture mainkan peranan yang sangat penting dalam menyediakan food and nutrition service, but also as a source of profit. Okay, dia mendatangkan keuntungan for some of 820 million population all around the world. So, with this scenario, effective management of the region's inland and coastal area as well as its oceans is therefore necessary to enhance the production trend of fisheries and aquaculture in Southeast Asia and ensure food security for people not only in Southeast Asia region but also in the world. So efficient fisheries management is essential for sustainable exploration. Jadi kalau kita tak kawal dan fisheries ni dengan cara yang sustainable, yang lestari, nanti stok perikanan kita akan habis. So sustainable and productive fisheries improve food, nutrition security and promote economic growth. Okay. So itu saja. Thank you.
Thank you very much, Dr. Yeni. Thank you for giving a lecture today. And student, time for question. Please, you can directly ask Dr. Yeni, or maybe if you are not so good enough in your internet connection, please send chat to me or to this chat room. Please, student. Angelia, looks like you want to say something.
Excuse me,
okay.
I want to ask.
Okay, Lutfia, please.
Okay, I want to ask to Dr. Yeni, what satellite data is often used for GIS processes? Thank you.
Still, Dr. Yeni, still mute your microphone.
Sorry, okay. So for my study, I use SST, chlorophyll and SSH. Jadi untuk chlorophyll dan SST, saya menggunakan data MODIS, Aqua MODIS. Untuk SSH, guna data dari Aviso. Yeah.
Lutfia?
Enough. Thank you, Dr. Yeni.
Okay.
Dr. Yeni, is there another satellite to replace the MODIS satellite? I mean, maybe is there another oceanographic satellite can we use as a primary data to get oceanographic data, and also after that we can make some model to predict which area is potential or not?
I think there's a lot of selain daripada Aqua MODIS, ada juga a few yang lain yang provide data satellite. Macam kita boleh download data tu daripada Ocean Color kan, website Ocean Color. Jadi di situ dia akan menunjukkan satellite apa, data apa, bulan bila, hari apa, bergantung kepada keadaan tempat yang kita nak tu kan. Jadi there are a few options.
Okay, thank you, Dr. Yeni. Is there any other question, student? Student, you look so tired today. You have so many classes. Please, Faras, I think you have some question, Faras.
No,
Huh?
because hari ni, today we have new students. New semester is beginning next week. So we have new students from tahun 1 baru masuk. Jadi pagi tadi
Yeah.
ada orientasi.
Oh, okay.
Orientasi bersama tetap pelajar tahun 1.
Oh, okay. Okay, so
In the morning, yeah.
the new semester in Malaysia is start from
Yes,
October?
October to February.
February, yeah.
Yes.
Yeah.
Yeah. Semester
Here,
1.
yeah, here commonly start from the end of August until December.
Oh.
Yeah.
Oh, you're almost finishing.
Yeah, almost finished. Okay, student, any question? Angelia, Faras?
Excuse me, can
okay.
I ask?
Yes, sir.
Oh, Maulana, okay. Maybe after Maulana, Faras. I think.
Oh. Okay. Thank you for the time. I want to ask to Dr. Yani, how management fisheries in Malaysia and how strategy fisheries in Malaysia with the condition oceanography in there. Thank you.
Pardon again, Maulana cakap Melayu je, cakap Indonesia je.
Cakap Maulana.
Cakap Indonesia. Lagi sekali soalan Maulana.
Cakap bahasa nggak apa-apa, Maulana.
Boleh cakap Indonesia.
Yeah.
Tadi tak dengar soalan Maulana.
Maulana, Mike, unmute. Yeah.
Okay. My question is, how is fisheries management in Malaysia with the oceanographic condition? Is there?
Okay.
Sorry,
fisheries management.
Bahasa.
Sorry.
Fisheries management. Okay, I think it's the same with Indonesia. Okay, whatever the scientists say, usually the government won't listen to us, basically. So, yeah, it's the same. We have a lot of species overexploited that needs better management. But so far, I think we need to apply more strict fisheries management, or else our stock fish also will be overexploited and soon will be gone from our fish, from our oceans. Yeah, and also there will be climate change. So climate change also akan menyebabkan masalah kepada stok perikanan tu. Jadi we also need Malaysia also need more sustainable fisheries management. Yeah.
Okay, thank you.
Okay, Dr. Yani, so how is the percentage, I mean, between the overexploited and maybe underexploited? Which one is the highest number in Malaysia? Almost similar?
For other species, I'm not sure. But for mackerel, which I study mackerel, it's almost 40% of mackerel is already overexploited. So because in Malaysia we also eat mackerel a lot, so that's why. So the fishermen will, yeah.
So the highest production of the catch is the mackerel in Malaysia?
Yeah, mackerel. Yeah, mackerel. Mackerel, and then we have scat. Pelaling, ikan pelaling.
Yeah. Okay, thank you. Student, please.
Answer.
Okay. Go on.
Thank you, Mr. Abu. My name is Farah Sedera Fifa, and I have one question for Dr. Yeni. I'm sorry if my question is a little outside the material today.
Okay. It's okay. It's okay.
Thank you. I want to ask you about the events in the ocean. It namely Milky Sea. What are the fisheries oceanographic factors that can affect the Milky Sea?
Milky Sea.
Yes. Can it only be in a certain place in the Indian Ocean, or it can be happen in other place, or can it's only can be happen in Indian Ocean. Then what impact the Milky Sea has on fisheries in general? Thank you.
Okay.
Thank you, Faras.
Milky Sea. What is Milky Sea? Laut yang tak jernih ya? Laut yang kotor Macam mana? Milky Sea?
Milky Sea. Milky Sea, laut yang bercahaya.
Like bioluminescence.
Yes,
Something
sir.
like bioluminescence.
Bioluminescence. Okay. There's no bioluminescence in Malaysia, but I know there's one in Bali, is it? Ada satu di Bali ya? Okay. So jadi saya pun tak pernah tengok pantai yang bioluminescence. So I'm not sure about the phenomena. Yeah, I'm not sure what caused the bioluminescence and why it occur in certain places. Okay. Ke Pak Abu tahu? Ke Dr. Abu Bakar tahu?
No.
Bioluminescence.
Is there any
Because di Malaysia tak ada.
Is it
Di Australia mungkin ada.
Yeah. Mostly in the Indian Ocean, but I don't know exactly.
Di Maldives, di Maldives, tapi di Malaysia tak ada. Jadi why it happened and what caused, I'm not sure. Okay.
It could be caused by the physical oceanographic or the integration with the chemical oceanographic factor, I think. But I have no idea about this one. Thank you.
Ada satu soalan di chat daripada Shadia.
Shadia. Faras, that's okay, Faras?
Okay, what's the difference between data remote sensing and GIS? Which one is more commonly used? Okay, so for marine fisheries, we use both, okay, remote sensing and GIS. So remote sensing maksudnya data yang dari SST dan chlorophyll, dan data tu kita integrate, kita masukkan dalam GIS untuk dapatkan potential area bidang di mana mereka menggunakan GIS untuk locate haiwan yang lain, contohnya seperti gajah, harimau, okay, dan dia also menggunakan data remote sensing, tapi bukan SST lah, SST dan chlorophyll dia guna lain, okay, tapi mungkin dia guna temperature but not sea surface temperature. Jadi daripada data itu juga kita boleh dapat kawasan untuk haiwan yang lain. Contohnya di hutan, mangrove pun kita gunakan GIS. Untuk topografi bandar pun kita guna GIS. So untuk topografi mungkin kita tak guna data remote sensing. Tapi untuk contohnya macam data seperti hujan, kita akan pakai remote sensing. So it's better we combine both untuk dapatkan more effective ways. Okay, so kita nampak a bigger picture. Okay.
Okay.
Thank you.
Okay, thank you very much, Shadia Fahma. Your name looks like a Malaysian's name. Yeah. Okay, thank you very much, Dr. Yeni. So for the accuracy, is it we need the field survey?
Yes. Okay, we can come up with numbers, tapi numbers tu kena accurate. untuk menunjukkan yang map itu tepat atau tidak tepat. So usually kita akan menggunakan accuracy test seperti kappa accuracy, dan juga kalau macam kita guna statistical analysis, usually dia akan ada AUC. So that numbers usually kalau 75 ke atas atau 80% itu sudah bagus. Itu yang bagus. Jadi kita perlu accuracy test supaya map itu lebih accurate. Okay.
Ya, thank you Dr. Yeni. Jadi students, saat kita menggunakan data-data satelit, kemudian when we analyze using satellites data, and also kita menganalisis menggunakan geographical information system, penting untuk ada data lapang untuk menghitung akurasinya. Dr. Yeni, I think this is the last question. Remote sensing GIS, can we apply the remote sensing and GIS to determine abundance of coral reef? So for coral reef mapping.
Yes, can. Kita boleh guna remote sensing dan GIS untuk coral reef mapping, boleh. Tapi how use macam mana method untuk coral mapping mungkin berbeza dengan ikan. Okay, kalau ikan kita akan ada data fishing, kita akan ada data perikanan di mana ikan tu ditangkap, location, lat long, okay. Tapi kalau untuk coral mungkin kita akan guna data topografi atau bathymetry. Sebab coral tidak bergerak kan, jadi mungkin metodnya berbeza, tapi boleh digunakan remote sensing dan GIS.
Okay. Okay, thank you very much.
Thank you.
Ganantara, this okay? Yeah, I think okay. Are you okay, Ganantara? Yeah. Okay. Okay, thank you very much, student. Is there any other question, please? Dr. Yeni, commonly in UMT, how many students in one class?
Untuk subjek, core subject, usually around 50 to 60, ya. Untuk elective mungkin 30.
Okay.
Yeah.
Okay. So the Fisheries Oceanography is core subject, right? Or elective?
It's elective.
Elective.
Elective. Tapi
Okay.
saya rasa kalau Fisheries Oceanography di Indonesia mungkin lebih bagus sebab saya I also use many reference from Indonesia. So usually in my lab there's one Indonesia, Suhartono, Abang Suhartono pun buat sama, dia dari Makassar. Dan jadi saya
Pak Zainuddin, ya. Maybe you know.
Yeah, Pak Zainuddin. Yes, I also use him a lot for my references.
Yeah.
Pak Zainuddin, Suhartono Nurdin. I think Pak Zainuddin is very, very good in Fisheries Oceanography. So many papers. Yeah, I use a lot of his papers as my reference also.
Okay. So
Pak Zainuddin with my supervisor, they studied in the same place in Hokkaido University.
In Hokkaido University, yes.
Yeah,
so,
with my supervisor, same.
Oh, with the professor.
Saito. Yeah, Saito. Yeah.
Yeah, I know him. And Pak Zainuddin is my best friend.
Oh, okay.
Because we are in the same research area, so yeah.
Pak Zainuddin in Makassar, ya?
Yeah, University Hasanuddin. Yeah.
Okay.
Thank you very much. Student, is there any other question? I think there is no more question, and time is up, Dr. Yeni.
Thank you.
We are so lucky for having you today and yesterday, Dr. Yeni. And student, we will have another class on 14 October. Dr. Yeni, yeah. So 14 October, we
Yeah.
will have a class in the topic of data and method in fisheries and oceanography, and also the same topic, Dr. Yeni will give also next week for another class. So for class P03 will be 13 October, and this class P02 will be 14 October in the same time, Indonesian time. Thank you very much,
Okay, thank
Dr.
you.
Yeni. Thank you very much for giving
Thank you,
us this
everyone.
very
Alright.
good topics. Thank you. See you. Keep healthy,
Okay.
Dr. Yeni.
Okay,
Keep healthy,
Assalamualaikum. Thank you.
all the students.
Yeah.
Thank you.
Thank you, Maulana.
Maulana.
Thank you, Pak Abu Bakar.
Thank you. Terkenal.
Okay.
Thank you. See you all. Keep healthy.